Hi again, guys. Now, in this tutorial, they tell you in the first question, in a survey of 900 Canadians, 940 Canadians, 720 of them say yes for that the energy situation in Canada is very serious. Okay, so whatever, 720 out of 940 say yes, it's serious. First question, they want the point estimate. Point estimate in this case would be P hat, and that's sample proportion, which is 720 out of 940. It's the percentage from the question, 720 over, and that would be 766 if you use 3 decimal places. Question 2. 95 confidence interval. So they want 95 confidence interval for proportion. The formula we use for the confidence interval proportion is P hat, the one we just did, plus or minus Z star, so not T star, Z star, and we go square root P hat 1 minus P hat over N. This is the formula we go by when we do a confidence interval. Now, the first question, they divided this into steps. The first step is, what's the critical value? Z star is your critical value. So also for the T one, T star, anything star that's in part of the confidence interval, it'd be critical value. How do you get this? Now, although it's Z, we don't get it from the Z table. We get it from the T table. It's much faster to get it from the T table. Remember, it's 95. So you go to the T table. In the degrees freedom, you go to the degree freedom infinity. And in that line infinity, you see what's the common number between infinity and 95? You'll see it's 196. That's the number you go with critical value. In the B question, so A was only the critical value. B was, what's the margin of error? And I said this earlier. What comes after the plus minus? That's your margin of error. So your margin of error in this case would be Z star, and that's 196, square root P hat 1 minus P hat over N, and that's the entire group 940. So we do this, 766 times 1 minus the 766 divide, 1 minus 766, now divide this by 940, square root it, times 196, you get a margin of error of 271, about 0.271. And then they ask, okay, once you have the margin of error, so you have P hat plus or minus the margin of error. So you have P hat, which is the 766, and the margin of error is the 271. Then you can get the lower point, you can get the upper point. Lower point, you would minus them. Upper point, you would add them. So I'm not going to do this, but that's the idea. And then there's another question. I'm going to erase this. Question 3. The minimum sample size needed. So the question is for sample size. Minimum sample size for proportion. So I know it's sample size proportion and it's at 99%. Sample size would be n. So you're looking for n and it's 99%. They tell you do it, this sample size, within 4%. What's the sample size? Okay, now I'll tell you how to do this, but they divided this into steps, which is not bad. The first question is, what's your critical value? Critical value would be your z star. So again, you get it from the t-table, you go to the infinity, but this time it's a number that goes with 99%, 2.576. So your critical is 2.576. What's your margin of error? Margin of error in this case would be whatever they give you after the within. Within means plus minus, and we know what comes after the plus minus is the margin of error, so your margin of error would be 4%. And then say, what's the sample size? Now for the sample size n, we follow this formula. Z star times, D star over the margin of error squared times 50 times 50. So your Z star is 2.576, your margin of error is 4%, you square this, and then 50 times 50. I'll do this quickly, so 2.576 over the 4% squared and 50, my sample size would be 1036.84. It doesn't matter what you see after the decimal, even if it's 0.1, you always round up. So sample would be 1037. So even if it's 0.1, you ignore and you add 1. So you always round up. So that's the first question in the tutorial. Question 2. Okay, question 2. So let me just erase some of this. Education rehearsal claims, so there is a claim that at most 5% of working college students are employed as teachers. So people graduating and working as teachers. So now we're gonna test this. We take a sample of 250 and we found 15 of them working as teachers. Using alpha of 5%. Okay, the question is, can you support the claim? Is the claim valid? We're testing the claim. First question. 1. Find the proportion of students from the sample working teachers. So from the sample, what's the percentage of students working as teachers? So that's asking for p hat. 15 working as teachers from 250, and that's 6%. That's your sample proportion. In question 2, what's your null hypothesis? What's your alternative? The null hypothesis is always equal. So you say P equals the 5% of the claim. Here, we're trying to prove that the claim is wrong. So they say at most 5%. We're trying to prove them wrong, that the P is more than 5%. And again, that would make this a one-tail system. They want to test the success and failure. Success and failure, if this condition is met. Now, for the success, you take your n times P, and for the failure, you take n times 1 minus p, and if these numbers are more than 10, condition is satisfied. So it's 250 times 5%, and it's 250 times 1 minus the 5%. So 250 and 5%, here you have 12.5, here you have 237.5, both numbers more than 10. So the condition, yes, it's satisfied. Now, what's your observed test? So what's the test in this case? I'll just move this. Test for this kind of hypothesis would be z-test. Proportion is z, not like the mean we did, the t in the previous question. The formula would be p hat minus p square root p 1 minus p over n. P hat being the 6%, p is the 5%, this is 5%, 1 minus 5% over the sample in the question, and that's 250. You do this, and the answer would be 725. What's the p-value in this question? Now, the idea of how to find the p-value, I'll use this here. To do the p-value for a z-test, since you're testing more, remember probability when z is more, 1 minus table, same idea. So your p-value would be 1 minus whatever this number is from the table. So you can round it to 7.3 and look it up. So I actually did this earlier to look up what the percentage is for this. It would be 7.658, and the answer would be p-value 2342, about 23%. Now, is there evidence to support the claim at 5%? Do we support the claim? Do we accept HA? Do we reject HA? Reject H0, or we don't reject H0? Now, I told you the answer in the previous question. Again, p-value less than or equal alpha, you reject H0. P-value more than alpha, we don't reject. In terms of supporting, basically now you're trying to see if you're supporting or not at 5% level of significance. Now your p-value is 23%. Alpha is 5%. You're more. P-value is more than alpha. So you don't reject. The answer is no. We don't support the claim. So this is it. So what I want you guys to do is look at the video for the first time. Try and do the assignment. If you have a problem, you can either email me, take a picture and email it to me, or to make life easy, I'm gonna give you my number, 902-452-8893. This is my cell number. So if you have a problem, if you can't find the answer for one of the questions, take a picture of the question and text it to me. I'll tell you what the answer is. But try it first. Hopefully this clarifies everything. I'm gonna post another video later for the last assignment, and maybe I'll try and also help you with the final exam somehow. I'll figure out a way. Thank you, everyone.